of freezing point. The third most important colligative property. This is mainly denoted by delta TF, that is depression of freezing point. When you add solute in a solvent, its freezing point of a solution mainly decreases. Okay, now tell me, what is freezing point? What is freezing point? The freezing point of a substance may be defined as the temperature at which the vapor pressure of liquid becomes equal to the vapor pressure of a corresponding solid. Where the vapor pressure of a solid is equal to the vapor pressure of a liquid is called as freezing point. At the freezing point of a substance, the solid phase is in equilibrium with the liquid phase. When the freezing point takes place, compulsorily the equilibrium must be taken place between the solid and liquid. Thus, the freezing point of a substance may be defined as the temperature at which the vapor pressure of liquid is equal to the vapor pressure of a corresponding solid. Okay, here the temperature at which the vapor pressure of liquid becomes equal to the vapor pressure of a corresponding solid, this stage is called as freezing point. Addition of a non-volatile solute to a solvent lowers the vapor pressure of the solvent. Okay, when you add non-volatile, what is non-volatile? Which is not getting vaporized, which will not get vaporized easily, is called as non-volatile solute to a solvent. It will decrease the vapor pressure of the solvent. Therefore, the solvent will be equilibrium with the solid at a lower pressure, hence at a lower temperature. Thus, the freezing point of a solvent decreases. How the freezing point of a solvent decreases? When you add non-volatile solute to a solvent, this will lowers the vapor pressure of the solvent, and the solvent will be equilibrium with the solid, obviously at a lower pressure and also at a lower temperature. Thus the freezing point decreases. How? On adding solute in a solvent, its freezing point in a solution mainly decreases. Depression of freezing point. What is depression of freezing point? The decrease in the freezing point of a pure solvent by addition of solute to it is known as depression of freezing point. The decrease in the freezing point when you add solute to the pure solvent, it is called as depression of freezing point. Okay, this is the graph for depression of freezing point. Let us consider this is a point of a pure solvent. This is a point of a pure solvent and this is a point of a solution. The graph is plotted against vapor pressure and the temperature. When you decrease the temperature, a point is reached where liquid and solid are in equilibrium. When liquid and solid are in equilibrium. Here T2 is the freezing point of the, T2 is the freezing point of a pure solvent and T1 is the freezing point of a solution. Freezing point diffraction can be found out, that is delta TF is equal to T1 minus T2. Okay. Let T2 be the freezing point of pure solvent and T1 be the freezing point of a solution. Here the freezing point diffraction is delta TF T1 minus T2. For dilute solutions, depression in freezing point is directly proportional to the molality of the solution. Here delta TF, this delta TF is directly proportional to M. Okay. Directly proportional to M. When you remove this proportionality constant and put the equal sign, you will get the Kf constant. The proportionality constant Kf mainly depends upon the nature of solvent. It mainly depends on the nature of the solvent. How the pure solvent is present or the solvent is present is known as freezing point depression constant. This Kf is also called as freezing point depression constant or molar depression constant or chrysopic constant. The unit of Kf is kg per mole. The unit of Kf is kg per mole. This is the graph. the diagram showing delta Tf depression of the freezing point of a solvent in a solution. We have got the equation called as delta Tf is directly proportional to Kf and m. Okay, if W2 grams of solute of molar mass M2 is dissolved in a W1 grams of solvent, the molality of the solution depends. M is equal to W2 into 1000 divided by M2 into W1. What is the value of M? We have already learned in the expressing the concentration of solution. The value of M is W2 into 1000 divided by M2 into W1. When you put this value of N in this equation, you get delta Tf is equal to Kfm becomes delta Tf is equal to Kf W2 into 1000 M2 into W1. This is the equation formed. This is the, we can find out molar mass of the solute when you take molar mass in this side. We can calculate the molar mass of solute, that is M2, easily.